Question 5 of our June paper 2 was our general trigonometry questions, starting with, this is where you actually have to go draw a triangle for yourself. So they're saying sin 40 is equal to p. In other words, it's equal to p over 1. Write each of the following in terms of p. Okay, so 40 is in quadrant 1. So you go draw your triangle. This is 40. Meaning, if this is 90, this one has to be 50. Then, it's p over 1, so it's p over 1, opposite over hypotenuse. And you will find this other one with Pythagoras. It will be 1 minus p squared, if you go do your whole Pythagoras. So they're asking you for sin 220. So firstly, you're going to have to reduce this. So 220 is in quadrant 3. So it will be 180 plus something, and more specifically, it's plus 40. Then you go ask yourself, okay, so in quadrant 3, this is quadrant 3. In quadrant 3, sign is negative, so it will be negative sin 40. Okay, and then negative, we know sin 40 is p, so negative p. Then cos squared 50. So either you can go do your cofunctions, you're allowed to go change this to sin squared 40, right? Because they are complementary. 40 plus 50 is 90. Or you could have said, okay, 50 is there. And then cos of that would be p over 1, which is just p, and it's p squared. So your answer here is p squared. For question 2, we have to prove an identity. Okay, so we know when we're proving an identity, you need to start on one side and make your way to the other side. And usually take the one that has more going on. Okay, these are both looking very complex. So I would start with this side, with our left-hand side, because we see there's a tan, which we can change. We see this, which should be making us think of sin squared, right? So that's where I would start. I would start by changing tan with sin x over cos x, or replacing it. And then I would replace 1 minus cos squared x with sin squared x. Now, look where we're going. Okay? It's not very, very clear, but we know cos needs to be a denominator. Cos is a denominator. Okay, so we need to get this as one fraction. Cos x at the bottom. Then we have sin x times sin to the power 2x. Okay, so we actually have 3 sin x's. Plus, we are multiplying this currently. It's over 1. But you want it to be over cos, so you multiply with cos x at the bottom. And on top, so we now have 3 cos x's. And now you need to dig deep, because we haven't done this in a while. But this is a cube, and that's a cube, and they're being added. Okay? We're not there yet. Okay? But do you see this bracket here in front? It's just a sin x and a cos x, which is what's hinting you towards you have to be factorizing now. So, cubes have a small bracket and a big bracket. I'm just going to zoom in a bit so we can write a bit better. Sin x plus cos x, because that's what's being squared. Then you ignore that. The first term in these 3 brackets is going to be that first one squared. And then this one squared at the back. This one is always positive, that one is always positive. And the middle term will have the opposite sign from what's there. And then for a middle term, we just multiply those two. Okay, you kind of see it's now looking almost like that. Okay, you have this bracket sorted. You have the cos x sorted. And you have this term. Okay, do you see you have that term? So how are we going to change sin squared plus cos squared to 1? And then a light bulb should be going on, because you know that, right? We know that sin squared plus cos squared is 1. So then for your last step, you just go replace sin squared plus cos squared with 1, so that your final answer all over cos x is this bracket, blah, blah, blah. And then I'm going to just quickly go double check. We want the 1 to be first. Okay. So you say 1 minus sin x, cos x, and you're done. And then they're asking you for which values in the interval from negative 180 to positive 180. Will this be undefined? Okay. If you go look at undefined, we are specifically looking at denominators being 0. So you have to look at where's cos x 0, and then also tan, where tan is undefined. And then because you know your theory, you know this is exactly the same place. Okay, tan x is only undefined at 90 and 270 because tan is sin over cos. You can't divide by 0. So where cos x is 0, which is 90 and 270. But they're not asking for you in that interval. Okay. So if you want to go write it as a general solution, it's at 90 and then every 180 degrees. Okay. Okay, being z, but that's not what they're asking, so you won't get marks for this. It is actually at 90, and then when k is negative 1, the other one will be negative 90. Those are your two answers, 90 and negative 90. Then, given the expression, sin 150 plus cos squared x minus 1 over 2, without the use of the calculator, simplify the expression given to a single trigonometric term of cos 2x. Okay. So, we need to get this to be one term. And it's in terms of that. So it won't necessarily be straight, this answer. Okay, so let's see what we can do here, okay? 150, okay, we know is 180 minus 30. And we can find sin 30's answer, and we know that even without the use of a calculator because it's one of our special angles. So maybe we can start by saying sin 150 is the same as 180 minus is in quadrant 2, so sin is positive, so it's positive sin 30, which is a half. Okay, that's one of the parts we can do. What we're working towards is cos 2x. So we know we're probably going to use one of these. And we're going to change this to a half. Maybe we could change this to be sin squared, right? But it has to be negative sin squared. So let's see if that works. Okay, I'm going to zoom in a little bit again so we just can see a little bit better. So we're going to change it to a half. But this is not on the right form because sin squared is 1 minus cos squared. So if you take a minus out, then you have 1 minus cos squared x, okay, which we know is sin squared. We have a half minus sin squared x over 2. Okay. Are we starting to see it looks almost like this one? Okay. But that should be a 1 and that should be a 2. Currently it's a half and 1, which 1 is double a half. So you can rewrite this. So let's just, to make it easier for ourselves, rewrite it as times a half. And then we have a half minus sin squared x. Okay, instead of dividing by 2, writing it as times a half. And we have a half, right? This is one fraction. Okay, this was quite a tricky question. So if you want to multiply, or this have 1 as a denominator, we have to multiply with 2. So this is 2 sin squared x. Okay, you see now, this is cos 2x. So we have a half times cos 2x over 2. And then just multiply on top, multiply at the bottom. So you'll get cos 2x over 4. Right, so this was a lot of work and a lot of brain power. But you kind of needed to do this question to be able to answer the next one, which is our general solution question. And they're asking you, this thingy that we just found out is actually cos 2x over 4 equal to that. So then if you want to multiply with 4, it's cos 2x is equal to 4 over 25. Okay, you don't go divide by 2 or whatever. You're finding your reference angle from here. So your reference angle, you find with arc cos of 4 over 25. And you should be getting 80,79. Where are we finding positive cos? So if we look at our cos diagram, cos is positive in quadrant 4 and in quadrant 1. So in quadrant 1, you will have 2x is equal to 80,79 plus k 360. So we divide by 2. So it's 40,40,40 plus k 180. Remember, you divide by 2 in each of the terms. And then in quadrant 4, okay, you could have done this actually 2 ways. I'm going to show you the one first. So 2x is equal to, in quadrant 4, we have 360 minus, okay, which was 80,79 plus k 360. Okay, you add those together and then you divide by 2 to get x. So you should be getting 139,60 plus k 180. That's one of the ones you could have had. Alternatively, instead of saying this is 360 minus theta, you could have also said it's just minus theta. So alternative answer for this one. Not for that one, you need this answer. Alternative answer would have been x is equal to negative 40,40 plus k 180. And then there's something you have to remember, otherwise you're going to lose marks. This is very important. You have to add k is an integer. Yeah, and that's it for general trigonometry.